Hey there. Today what we're going to be doing is looking at solving any triangle, and we're going to be looking at the law of sines. So we've solved triangles, but what can we do when the triangle doesn't have a right angle? When we know two angles and a side, or two angles and an angle opposite one of those sides, we can use the law of sines. Now, back when you guys were proving triangles congruent in geometry, you had things like SSS, SAS, that kind of stuff, right? Well, this isn't proving triangles congruent, but depending on the type of information that you're given about the triangle, that's when we're able to use the law of sines. So the law of sines is when we have an AAS case. An AAS case is if we're given an angle, and then like a side that's not included. It also could be if we have an angle side angle case. That means that we have a side that is included between the two given angles. And then there's a special case we'll spend a little more time on going forward, like not today. That's the SSA case. Now remember, the SSA case in geometry, you couldn't prove a triangle congruent. You remember why, but it causes issues with the law of sines. We can use it, but we're going to have to be a little careful. But with that kind of information, we're able to solve a triangle with the law of sines. And we can do this for any triangle, regardless of if it has a right angle or not. So that's what's kind of nice about it. So for triangle ABC with side lengths A, B, and C, we can use this, that A, which is a side length, over the sine of angle A, equals side B over the sine of angle B, which also equals C over the sine of C. So I want you just to take a look at each ratio. Okay, each ratio is a side length and then divided by the sine. And then notice that those are like the same letters, except one's uppercase and one's lowercase. The lowercase means the side, and then the uppercase means the angle. And it's the angle opposite that side. So if we have a side and an angle opposite that we know, we have enough information that we can set up the law of sines. Okay, so this is kind of like our big thing here. Okay, that idea that the ratio is the side length over the sine of the angle opposite that side is what we're going to use to set up our proportions. We're not going to use all three at once. We're just going to use two of them and then go from there. So example 1 says to solve triangle ABC, and today we're going to focus on angle, side, and side, angle cases, okay? So in example 1A, it says that the measure of angle B is 34 degrees, the measure of angle C is 100, and B is 8. I just kind of want to sketch, and again, this is clearly not to scale, but notice that you're given information about angle B, you're given information about angle C, and you're given information about side B, which is across from angle B. So that is an angle, side case. And this is enough information for us to use the law of sines. And look what we have here. We have an angle B and we have a side B. And that's what we're going to do to set up our ratio. So we can take 8 over the sine of 34 degrees. And they also give us the measure of angle C. That means that we can find side C as well. 100 degrees is an angle, so we're going to put the sine of 100 degrees in the denominator. And since this was angle C, we're going to set that equal to side C as the other part of the proportion. Okay? And that's all we're going to deal with for now. Now, to solve this, what we want to do is we want to cross multiply. That's how we solve proportions. So we will cross multiply in this fashion. And notice I have C times the sine of 34 degrees and I have 8 times the sine of 100 degrees. And again, those are equal to each other when we have a proportion and we solve by cross multiplying, okay? Now the goal is to get C by itself, and we can pretty easily see that we can get rid of this multiplication by division. So we can say that C is going to be 8 times the sine of 100 over the sine of 34 degrees. And that's when we get our calculator out. Now remember, make sure that our calculator is in degree mode, okay? And then as long as it's in degree mode, we can just type this right into the calculator. 8 times the sine of 100 divided by the sine of 34. And what this tells us is that C, we're going to round to the nearest tenth, by the way. C is about 14.1 units. Okay, great. Now you might say, well, that's fun, we're done. We're not. Remember what it means to solve a triangle? To solve a triangle means we want to find all the sides and all the angles. Well, we have side B and angle B. We now have side C and angle C. So what's missing? That's right, side A is missing and angle A is missing. So how in the heck are we supposed to find angle A? Well, remember, when you're given two angles of a triangle, we can find the third angle by subtracting that from 180. So what we can do is take 180 degrees minus angle B, which was 34 degrees, minus 100 degrees, and that's going to tell me the measure of angle A. Because we knew angle B and angle C exactly, I can put an exactly equal sign by that measure of angle A. And so if I take 180 minus 34 minus 100, I get that the measure of angle A equals 46 degrees. Okay, now that we have that information, we can set up another proportion using the law of sines. Let's use the exact values that we had and not use that estimation. So let's use this 8 over the sine of 34 degrees again. And now let's use this angle A to help us out. So we'll have the sine of 46 degrees in the denominator. And then up top, I'm going to be finding angle A, or sorry, side A. And so then we can cross multiply. Again, I get A times the sine of 34 degrees equals 8 times the sine of 46 degrees. Remember, when you cross multiply in a proportion, which is an equation, we end up with another equation. And you might see what's going to happen after that. We'll see that A is going to be 8 times the sine of 46 degrees over the sine of 34 degrees. And then we can put that right in the calculator. So 8 times the sine of 46 degrees divided by the sine of 34 degrees. And that gives me about 10.3. So A is about 10.3. And now we know all the parts of that triangle. We have all angles A, B, and C, and we have all sides A, B, and C. And that's how we use the law of sines. So it's not too bad, right? Let's look at letter B. In letter B, we have that the measure of angle A is 51 degrees, the measure of angle B is 44 degrees, and that C is 11. If we think about that and just, again, have this random triangle ABC, we have angle A, we have angle B, and we have side C. So this is an angle side angle case. And that's a case where we can use the law of sines, okay? Now, in our last problem, we had an angle and a side that we could set up a ratio with for our proportion, but we don't have that this time. Or do we? Remember that we know two of the angles. So in order to set up our proportion with side C, we need to know angle C. And so to find that, we'll take 180 minus angle A, which is 51 degrees, minus angle B, which is 44 degrees. And when we subtract, we find that the measure of angle C is 85 degrees. And again, we know that exactly because there was no rounding that was involved, okay? And so these are the values that we're going to use as our like basic ratio for this proportion. We can take 11 over the sine of 85 degrees, side C over the sine of angle C. And then let's do A first. I'll go in alpha order. We don't have to, but we could. So angle A was 51 degrees. So that means I'll put side A on top here, and then I can cross multiply. And you might get to the point where you see what's going to happen in the cross multiplication. To find side A, we see that we would be multiplying 11 times the sine of 51 degrees, and then divide by the sine of 85 degrees. Now, if you can't jump right to there, please feel free to do the regular cross multiplication and then isolate the variable. But I'm happy for you just to jump from the proportion to this. That's fine with me. So let's find what that is. I have 11 times the sine of 51 over the sine of 85. And to the nearest tenth, that gives me about 8.6 for side A. Once again, let's use that given, like the known exact side and angle values that we know for side C and angle C. And we'll use that to find the next piece. We have angle B, which is 44 degrees. So I can put side B over that. And then I can cross multiply these as well. And hopefully you guys see that to get side B, I would take 11 times the sine of 44 degrees and then divide that by the sine of 85 degrees. So 11 times the sine of 44 divided by the sine of 85. That means that our side B is going to be about 7.7. Okay, so why don't you guys try this next question? This question, we see we have angle A, angle C, and side B. So this is a angle, side, angle case. See if we can use the law of sines to find that. I'll give you a minute. Okay, so let's see how you guys did. The first thing that I did was I saw that I didn't have a ratio that I could set up right away, but I had two angles, and I started by finding the measure of angle B, which was 19 degrees. Then I saw that I could use side B and angle B to set up my ratio for the law of sines. And I did that for both angle A and angle C to help me find side A and side C. And then I cross multiplied and was able to get my results. This is the minimum number of steps that I'd like to see. I don't need to see the triangle sum theorem, okay? But I need to see whatever this angle is. I do want to see the setup for the proportion, the law of sines. I do want to see what you're putting in your calculator to get the answer, and also the final answer. And then the same is true for this other side. So for these problems, we need a minimum of like 7, steps, but that includes the 3 final answers. Okay, so I do want to see the proportion, the isolation of the variable that you're putting in your calculator, and then this answer. And then that being said, just remember that when you're putting things in the calculator, you do have to close the parentheses after the angle sign in order for you to get the appropriate answer. If you don't, you're going to get something completely different. Okay, so that's why I like to see this so I know where you're going wrong, if you're not getting the right answers, we can back up a little more easily, okay? So I have one more example to do with you today, and that's example 1C. And in this question, we are given that the measure of angle B is 104 degrees. And again, my triangles are not to scale. And that side B is 25, and that side C is 18. This is an SSA case. And we're going to have to be careful when we see these cases. Now, today we don't. Today I gave you ones that were nice. And I gave you ones that just have an obtuse angle. We'll talk more about that in another lesson. But going forward, we're going to have to be careful. But because I want you to be used to solving these types, I gave you ones that were safe today. And let's talk about how we could do this. Once again, I do have enough information for me to set up a ratio to help with the law of sines proportion. So I'm going to take here 25 over the sine of 104 degrees. Now what's different is that in the other questions we knew a second angle. This time we don't, but we can take, oh, whoops, sorry, side C is 18, my bad. So that's 18, and we're going to use that over the sine of angle C, which we don't know. So we're going to put that over the sine of C. So let's see what happens when we cross multiply with these. I have 25 times the sine of C equals 18 times the sine of 104 degrees. And again, we can see that to isolate the sine of C, I would have to divide both sides by 25. Now, in order for me to get to angle C, I have to get rid of the sine. Do you remember how we get rid of sine? Well, what we do is we take the inverse sine of both sides. And taking the inverse sine means that my measure of angle C will be the inverse sine of 18 times the sine of 104 degrees over 25. So that means that in the calculator, we can take inverse sine. So, oops, sorry. So I hit second sine, and then I'm going to put 18 times the sine of 104, close that one parenthesis around the 104, then divide by 25 and close the parentheses around the inverse sine. And this tells me that my measure of angle C is about 44.3 degrees. Okay? And then what we would want to do is we have both of the B, angle B and side B. We now have angle C and side C. So now we need to find angle A and side A. And since we have the two angles, I can take 180 minus the 104 minus the 44.3, and I get that this is 31.7. Now, in the past, when we were finding that, and this is going to be measure of angle A, we said that it was exactly equal. But isn't 44.3 an estimate? So that means that this is going to be an estimate as well. So that the measure of angle A is going to be 31.7. Now we can find the last side. Again, I'm going to use these two that I know for a fact, 25 and the sine of 104. And now I can set that equal to side A over the sine of 31.7 degrees. And this now, because I'm not finding an angle, looks much more similar to what we had done in the past in the other examples. So I can see this is going to be the same as 25 times the sine of 31.7 over the sine of 104. So let's see what that is. Again, we don't need inverse here, right? Because we're not looking for an angle. We're just taking 25 times the sine of 31.7 over the sine of 104. And that tells me that side A is about 13.5. Okay. So again, the steps I would want to see here are the setup. At the very minimum, what you're entering into the calculator, but all of this is okay as well. Okay. And the final answer. Okay. Again, the answer here, the setup, what you're putting in the calculator, and the answer. Make sure we have all those pieces. And then if we have all that, then it's going to be easy to see where we are or are not going wrong. Okay. So that's going to be what you're working on today. This is just a little preview and an FYI. I mentioned that caution has to be exercised when using law of sines in the SSA case. Depending on the relationship between the two sides, A and B, and this idea of the height of the triangle, the height is perpendicular to whatever like the base is considered. H is going to be considered B sine A. There could be no triangle, one triangle, or two triangles that are possible. And this is a flow chart that some Algebra 2 with trig teachers or pre-calc teachers have you learn. I'm going to teach you a different trick based on what we know about inverse trig functions. But this is kind of like what you might hear some other people in the other classes going through. This is not something that we're going to use, but if you hear other classes talk about it, I just wanted you to be aware of what that is. Again, they might have you learn these rules, but with our method, they're not necessary to know. And we'll talk about that in our next lesson, that sometimes we're going to have cases where there are no triangles. Sometimes there are going to be cases like we had today where there is one triangle. And then sometimes there are cases where there are two triangles, but we'll leave that for another lesson. Okay, make sure your calculator is in degree mode. You're using parentheses showing your steps, and have a great day.